We'll do 3.5. So in 3.4, we did solving inequalities using addition and subtraction. Now we're going to talk about solving inequalities using multiplication or division. Okay, when we're doing multiplication or division and inequalities, there's one thing that you need to worry about. Okay, and that is, so when we were doing equations and we came up to something that looked like this, what did we do? Okay, we would go ahead and divide both sides by 5 to get rid of the 5, and you have x is going to be equal to 9, right? This is what we did, right? So the equality is the same when you divide by 5, okay? Well, let's say that I change the question, and instead of 5, I put -5, okay? If I put -5 here, then what I'm going to do, I'm just going to divide by -5, right? I'm going to divide by -5. This cancels out. X is equal to, this is a positive divided by a negative. So it's a negative number, and it's going to be 9, right? That's your answer, okay? So this thing works the same, and when you're talking about inequality. So when I have inequality, if I have 5x is greater than 45, okay, I would divide both sides by 5. 5's cancel out. X is greater than 45 divided by 5 is 9. Okay, so that's your answer. Okay. Now, if I change the question again, and instead of 5x, I put -5x. Now, here's where you have to pay close attention. When you divide by or multiply, for that matter, a negative number. So I'm dividing by a negative number here. If I divide by a negative number, now this go ahead and cancels out. I get x here. Again, the same thing here. I have positive divided by negative, so it's going to be -9. However, when you divide or multiply by a negative number, you flip the inequality. So the inequality becomes this. So this is the biggest difference. When you are multiplying or dividing an inequality by a negative number, you always flip the inequality sign here. So in other words, if I had something that looked like -10, let's say that I had negative x over 2 is greater than equal to 10, right? Now here, you're going to go ahead and multiply both sides by -2. I'm going to go multiply both sides by -2, because now this guy and this guy cancels out, right? Because it's negative times a negative becomes positive. So I'm going to have x. When I multiply these two together, I get 10 times -2. Positive times a negative, the negative number, 20. Now I have to flip this sign because I multiplied by a negative number. So this sign now becomes this, okay? Because I have to flip the sign, okay? So if you go to page 146, in the middle, there's a multiplication property of inequality. If you read that, okay, it says that when you multiply each side of an inequality by a negative number, and you have to reverse the inequality symbols. Okay, you have to reverse the inequality symbol. Okay, on page 147, it says the same thing. When you're dividing by a negative number, dividing each side of an inequality by a negative number, then you have to reverse the direction of the inequality symbol, okay? Let's go ahead and do example 1 and see if we can actually put this into practice. So we're solving this. M okay. To solve this, I want m by itself. So in order to get m by itself, I need to get rid of the -3 here that is on the bottom. So I'm going to multiply everything by -3. Okay, so this guy now cancels out m. On this side, I have a positive number times a negative number. So it's a negative number, -9. But since I multiplied by a negative number, I have to flip this sign to look like this. Okay? Example number 2. Example number 2, I have -10t greater than or equal to 34. Okay, so what do I have here? I'm going to divide both sides by -10 to get rid of the -10 here. So this and this cancels out. I have t positive divided by a negative. So it's going to be a negative number. 34 divided by 10 is 3.4. Now I have to flip the sign. I have to flip this sign because I divided by a negative number, right? So I have to flip the sign. It looks like this. So t is going to be less than or equal to -3.4. Okay. Okay, last but not least, let's do example number 3. Example number 3 here. Example number 3, find the average speeds at which the flock of Canada geese described on page 146 can fly during migration. Okay, let's go back to page 146. It says, some flocks of Canada geese can fly nonstop for up to 16 hours. In this time, a flock can migrate as far as 848 miles. Whatever speed in a flock can learn in migration. So 16 hours. So if I take 16 hours, okay, 16 hours to travel 848, right? And this was the speed, right? The hours times the speed, right? Is the distance traveled, right? Because if I was traveling at 60 miles an hour and I went for 2 hours, that means it is 2 times 60, I traveled 120 hours, right? Same thing here, right? 16 hours at, I do not know which speed, right? You can travel up to this far, So it's going to look like this, right? That's going to look like that. So now I'm going to get, well, I want the x by itself. So I'm going to divide by 16. Okay, I did not divide by a negative number, so the equality sign stays, the inequality sign stays the same. Right, so I get 430.5, it looks like. Whoops. Never mind. So it goes into 580, 53. 53. So this is your answer. X is less than or equal to 53 miles per hour, right? Miles per hour, because this is miles, right? And this was hours. I divided by hours, so it's miles per hour. Okay. And that's it. Okay. Any questions on what we did this right here? Again, the important part here is to remember